sudden gust of wind or something like that. And then I'm like, Jesus, this is taking a long time.
Yeah.
Like that's a long, big gust of wind. And
Yeah.
then I realized, oh, there's no sound of wind outside. It's just like the whole building shaking.
Yep.
It's kind of bizarre.
Yeah. So, the Newcastle one,
Anyway,
essentially because Newcastle's on sand, liquefied, and then caused more damage.
Oh, really?
Yeah. That's
liquefaction, like of the
and there's a lot of
sinking and stuff.
Coal mines around Newcastle and things like that, as well as the coal mines and things like that, so you can get accentuated aspects to it. Yeah. So there we go.
When did that happen?
Newcastle, 89.
Yeah. Okay.
Well, we got a fair few people here, which is good. It's funny what happens when you say you're going to give some tips out for an exam.
Yeah.
Everyone turns up. Excellent. So any questions to start with? So everyone's sort of aware of the format of the exam. It'll be on, what is it, next Thursday or something? The 30th. I'm going to set a time limit onto it of 3 hours. So then it'll be open from, I just said nominally from 10 a.m. to 10 p.m. I presume most people are more likely to do it in the afternoon, evening. But let me know if you really want to do it at 6 a.m. or something like that. But then that means it'll just be on Moodle. So it'll pop up on Thursday and you'll just enter it like any other quiz. But you only get one attempt. And once you start, that clock's ticking, right? So be sure to blanket out your 3 hours. I don't think it'll take you a full 3 hours to do. I anticipated to be about a sort of 2 hours to 2.5 hours at the most. But make sure you blanket out that time so you get the opportunity to answer the questions. It's a mix of multiple choice, short answer, medium response, extended response. So there's a variety of questions in there. And many of them are randomized. So you get a diversity. And in terms of the extended response, you will have some options. So I'll show you some examples in a tick, but I'll get to that. So there's some old exams on Moodle. I hope some people have seen them. Don't get too freaked out. This exam's not exactly, I wouldn't say most of it's not as specific as this one. And so I can talk a bit more, but there's questions in there that give you an idea of sort of things to think about, and I'll try and help sort of focus that. So I can get to that in a tick. But so is there any questions about it, how it's set up or its format, anything like that? No?
No.
Happy days? Cool. All right. So what I'll do is I will share my screen. Okay. So this is just direct download from the Moodle page. I think this one's from 2014. So let's sort of look at what sort of things you might be expected in a sort of extended response. What are we? Where are we? So something like question 3, part 4. So outline the mechanisms of ore deposits in orogenic gold deposits. So you, in the extended response, you probably, how I've designed it is, I think there's 2 of them. They're 10-mark questions to give you an idea of how much to write. And there'll be, I think there's 4 options. So it's broadly like a question which is essentially describe how a SEDEX deposit might form. Would be a sort of style, or there'll be another option that might be, describe an orogenic gold and include a schematic of how the system operates. So they're sort of questions that are like, pretty much tell me how this works, and you can use figures. But there'll be 4 options. So if you look and you go, oh, I really hate SEDEX, or I really hate orogenic gold, or whatever, hopefully there's one there that you can you feel nice, warm, and fuzzy about, and you can pick that one and answer it. Okay. In terms of them, you sort of want to keep it focus around processes. That's what matters most. I'm not too worried if you can't remember the difference between a Cypress style VMS to a Broken Hill style or whatever. That stuff doesn't matter. Just describe the process of where the metals are coming from, how do they get there, what's unique about that sort of deposit, what would you expect to see, and so use sketches where you can. That'll definitely help go through that. So maybe there's some better ones in here. So yeah, so something like you might be looking at a SEDEX, so we might be talking about, if you remember the metal zonation, you can talk about that. What sort of tectonic environments, but I'm not going to ask you, something this specific. What are the typical footwall rocks associated with a Cypress type VMS deposit? That's getting a bit too nitty gritty for my liking. So when you do look at these older exam questions, don't get disheartened that you go, this is ridiculous. The exam's not that, it's not going to be like, here's 10 questions on VMS. I hope you know I hope you know them like the back of your hand. So there's not going to be sort of questions like that. But there will be things about maybe around typical ore minerals, or what sort of commodities they might be used for, just in a broad sense. Things around sort of broadly around alteration assemblages and alteration processes. So be wary about, thinking about what are the sort of common styles of alteration, how do they operate. What else is another? There'll be some questions on broader tectonics and ore deposits. So think about, what kind of, if, it says, might be something like, what kind of ore deposits do we expect in a subduction zone and why? And that might be a sort of medium extended response. So make sure you're putting contextive geological resources from the sort of hand sediment scale all the way up to the tectonic scale. So be wary of, where would we expect to see porphyry deposits or something, and why is that? Those sort of broader questions, whereas where else would we might expect to see a VMS? And so porphyry are more likely to be in a subduction zone because we need, magmatism and things like that, whereas VMS, they're commonly sort of at a mid-ocean ridge or in the deep ocean or something like that. Those sort of broader questions. So what else have we got here? Yeah, so explain how pegmatites form and what commodities. So that might be a sort of medium to extended response. So it gives you a fair bit of chance to describe the processes that are going on. So just be wary of how much marks are allocated, and that gives you an idea of, what you need to get to. So if it's, a 3-mark question, generally we're sort of looking for 3 points or a couple of points and a reasoning of why. those sort of things. So does that sort of help? The main thing is I left these quite early on in the semester, but I just want to be sure people don't look at these and just completely freak out that they're going to get an exam with, how many questions are there in here? There's a lot of questions in here. You know, that's like looking at that exam would probably take, I don't know, nearly 3 hours. And there's a lot of things that you're just like, you either know it or you don't. And so I tried to make it the exam so it gives people enough scope. There'll be, as always, there'll be questions that you either know or you won't know. So just do your best and try and work through the process. But in terms of the big mark ones, there should be plenty of scope for you to sort of work through something that you know and feel comfortable with. And like I say, just describe the process. Don't worry about getting caught up with too many of the technical terms or something like that. Just describe it out or draw it out. Use those use sketches to really help you communicate, because that's how we do it. You know, sketching something is, you know, so much easier than writing bloody lines and lines. What other things can I suggest? So I'm not going to get into the specifics of, like, you know, what are the name every 10 minerals that you would find in potassic alteration or something like that. Just build around the key ones. You know, what phthalic is mainly sericite, and this is why we get it because of a hydrolysis reaction, or those sort of broader features. Don't get caught up. Don't expect to be caught up with remembering, you know, 20 minerals that relate to a specific alteration or a specific ore deposit. Yes. So have we got any questions? Everyone's excited for the exam. Everyone's ready for the exam to be over. Yes, exams, that's the one thing I don't miss at all. So yeah, I'm sorry. I do sympathize with you, but yeah, by the end of my undergraduate, I'm like, I can't look at another exam again.
Oh, really? I don't mind exams, to be quite honest.
Okay.
I find I'd prefer, like, some of the units have been like, rather than an exam, you've got some big literature review or something like that to do, where you've got to summarize 20 papers or something like that.
Yep.
I'd prefer the exam, to be quite honest, than have to read through 20 papers. But yeah.
Well, it's the studying that got me. I was just like, just so sick of cramming.
Yeah.
But you know, I don't know. Maybe it'd be different if I had to go back and do one now, but I'm not in a rush.
I'm not a massively fast reader. I'm a little bit dyslexic, I think. And so reading, I wouldn't say I'm a slow reader, but I'm not like some people who can shoot through them like lightning, but I can spend a lot of time just reading through the material.
Yep. Oh, the other one that I was going to suggest is to think about will be sort of phase diagrams for all minerals, just thinking about what controls, you know, maybe different copper minerals, you know, just be wary, you know, might have questions like that to sort of be like, here's a phase diagram, what's controlling the stability of different ore minerals that it might be showing. So be wary to revise those ones. Is there anything else that has popped into my head?
Are all the questions covered in the lectures?
Most of them are based on lecture content. Yep.
Yeah.
But that doesn't mean that there'll be stuff that you can pull on from the practicals as well.
Okay.
So it's designed around the lecture content, but you by all means, if you go, this reminds me of, I don't know, the Glen Eden prospect or whatever that your company was involved in, by all means, provide an example of it. That's encouraged.
Okay.
So yes. So the only other one that I just popped into my head is also to think about things like metal enrichment, that side of those lectures, metal enrichment, what controls the ability of fluids to carry metals, why might they drop them out, those sort of things that we discussed earlier in semester to do with hydrothermal processes. Yep, and then there'll be different deposit styles that you'll have to touch on, but they're all broadly into the main breakup that I've done. So you might have a magmatic deposit, or you might have a massive sulfide deposit, or an orogenic gold. And the only other ones will be environmental issues. Yeah.
Right. Okay.
But they're broad. Yeah, they'll be more into your broader questions where you can tell me what you know about it.
Yeah. Right. Okay.
Yep.
Yep.
So yeah, and so by all means, try some of the questions that are the practice questions, or if you find one and you just go, is this the sort of thing I need to know? You just let me know, and I'll say, yeah, don't worry about that question. That's probably too hard, and just be thankful that you're not in 2014 or something.
Right. Yeah. Exactly.
And yeah, happy to help there. And
Okay.
yeah, so we're nearly there. Only a week to go.
Yeah. I haven't finished my Mount Mag yet.
No, I think a few people are in that vote.
Yeah.
As well. So yeah, so I'm happy to answer questions about that as well if people have got some questions.
Yeah. Well, just the main things like, so yeah, with the mineralogy of it, that's everything that's contained within that rock, pretty much, like with the mineralogy of it.
Yeah. So I mentioned this to a few people. So in terms of the mineralogy, so most of the rocks, they're dominated by 5 minerals.
Yeah.
So the mafic rocks, most of them will have plagioclase. There is 2 pyroxenes, so an orthopyroxene and a clinopyroxene, and then some might have olivine, and then there's chromite. I don't think there's much amphibole.
Right.
So they're the sort of 5 ones you're worried about. And for people that are having difficulties identifying them, let me know, and I'm happy to point out the features. So the plagioclase is usually, you can pick based on its colorless in plain polarized light, and that's twinned.
Yep.
Then the pyroxenes, distinguishing the pyroxenes can be a bit more challenging. But the orthopyroxenes usually sort of reddy brown color in plain polarized light.
Yep.
With cleavage, and the clinopyroxene is usually a greeny color with cleavage at 90 degrees, and the chromite's black. So that's for the mafic rocks. I think there's a granite in there, so that's at a slightly different end of the spectrum, but common mineralogy for granites, so you're more into your quartz, K feldspar, plagioclase. There's a biotite and amphibole.
Yep.
So in terms of those mineralogy, and then otherwise, I think I've been provided you with what else to expect. Have I missed anything? Anyone else there?
I just had a question about using image matrix.
Oh yeah, yeah. Some of them don't rotate. I have
Yeah,
to get.
that's what I was
Yeah.
going to say. Yeah, because I can't rotate the stage and see the extinction angles.
Yeah, yeah.
Yeah.
I have to get on to someone at and sort it out. But anyway, Macquarie's in lockdown, so they can't fix them. But yeah, so do your best. That probably makes picking the clino and orthoparoxene difficult. Would be the main challenge you face in these rocks. So if in doubt, if you can't pick them, just say pyroxene.
Right.
There is a really faint color difference between the two.
Yes,
That
you
you'll
can,
pick.
but you have to be careful because orthoparoxene can be red-green pleochroic. So there is a faint color difference. So it's probably okay. And technically, you also get a difference in birefringence. Clinopyroxene has second order. Orthoparoxene has high first order. But sometimes that doesn't always come out. And if you're being a real fuddy-duddy, there's 1 degree difference in their cleavage pattern too. Orthoparoxene's 88.92 and clinopyroxene's 87.93. But that's all right. So just do your best there. Yeah, I'm sorry about that.
Just so I don't get confused, what would the outcrop relationships refer to?
Whereabouts are you?
I just,
Map?
yeah, I just on each site, like each site on the paperwork, it says outcrop relationships.
Yeah, so some of them will have photos. So it'll be about like, is there layering in the outcrop,
Right.
or is it a steep vertical feature? The other thing to be wary there is to use the geological map.
Yep.
So there's no structural information on there, but you can actually gain it based on the relationship of the rock to the topographic contours.
Okay.
So
Okay.
contours are lines of equal height.
Yeah.
So by definition, they're a horizontal feature.
Yeah.
So if geological units follow contours, they have to be what orientation?
Right.
They'll have to be horizontal. If they cut them at a high angle, they'll be steeply dipping.
Right.
So you have to use those sort of features, especially when drawing the cross section as well.
Yeah, that's what I was looking for, the strike and the dip, but I couldn't find it. So I was thinking, so they'll all be vertical, except the intrusions will be horizontal, or I've got it the wrong way around.
No, I think there's a mix of both. So
Yeah.
see how the outcrop pattern, so how the boundaries of the geological units relate to the topographic contours, and that'll tell you if they're vertical or horizontal.
Okay.
And you can also start to pick up, because the topography shows sort of two hills.
Yeah.
One unit is on this hill and it's not in the other.
Yep.
So that presents a difficulty if that unit can't be horizontal.
Right. Yep, that's
Yeah.
right. Yep.
Yeah.
Okay. Thanks.
So yes, so back to your point, Josh, if you look at the sample site SA58 and you zoom right in, you can actually see orthopyroxene is a sort of browny red and the clinopyroxene is green in that sample. It's very fine grained. Yep. So there's the main mineralogy. They're very clean samples. Is there anything weird in the granite? So the granite has a bit of muscovite as well. So you pick biotite and muscovite based on their muscovite's colorless in plain polarized light. Biotite has that light to dark brown pleochroism. So there's not too many curveballs in there. Chromite will be the worst one.
What exactly do you want submitted? That whole sheet?
Yeah. So I think I put a guide there and then plus the cross section.
Yeah.
But that's just a sort of guide. If you have a better way to lay it out, that's fine too.
No, that's fine.
Yeah.
Just wanted to know. Yeah.
Yep.
So essentially you've got your one, I can't even remember which side it is now. Like two different vein events with different content. So you've got ones that are full of your pyrite, molybdenite, and all that, and then you've got your ones full of the that toluene, and I can't remember now, the purple muscovite and that.
Yep.
Are they caused by the
the lithium one? Yeah.
Yeah, the lithium one. Are they caused by the two different magmas?
Yeah, so that's something you have to sort of resolve. Yeah, based on how they relate, how the outcrops relate to each other. But you can also think about broader generic features. Would you expect to see, veining? Would you expect to see sort of a pegmatite plus a vein mineralization next to each other?
Yeah.
Or would that suggest it's a different style of deposit?
Yeah.
But the other advantage you have there is that they, the units cross-cut each other.
Yeah.
So that should help you sort of come up with a broader timing relationship.
Maybe.
Yep.
All right. Thank you.
So how's everyone else going with it?
Just on that same side F58 page, I was just looking at the bottom. With the pink tourmaline, it's got there as rubellite. Is that
that's
something?
a typo.
Okay, it's meant to be rubellite.
Rubellite.
Okay, I figured. Yeah.
Yep.
That's all right.
Rubellite. Sorry, I should pronounce it correctly.
Rubellite.
Yeah.
All right, lovely.
And Josh will be spending lots of time with green spodumene.
Hopefully, sure will.
You excited, mate?
Very.
Josh is one.
Regarding this pegmatite.
Yep.
Is that going to be coming out of like a fractionated magma as that Monzo granite is coming up?
So it's coming from a fractionated granite. A pegmatite is the last stage of a felsic intrusion. Well, actually, any intrusion. You can have rephrase. You can have a mafic pegmatite as well. So by definition, it's just something that's very rich in water, and it's the last thing to crystallize from a pluton. So we
can't draw conclusions about where it comes from, because otherwise I would expect tourmaline to be in the Monzo granite.
Yes, so you can start to draw conclusions based on genetic relationships between each other. So does it suggest that it is, do the field relationships suggest it was part of the Monzo granite? The other thing to think about is certain, so a lithium pegmatite is common for an S-type granite. We need
that's what I thought.
Yeah, we need a lot of sediment to incorporate those metals that we're interested in to form them. So that's where this sort of genetic relationship comes back to we have something that's what we would sort of call a sedimentary sourced melt. And then we have a big mafic intrusion, which has barely any, it's not very rich in aluminium because we're predominantly plagioclase and pyroxene.
Yeah.
It's not potassic. So I would, interpret that as broadly as like an I-type or something like that. So you have two very different intrusions next to each other.
Yeah.
And so that's where you have to sort of think about, do they make sense to be one? Or is there a difference? And then how does the Monzo granite fit into that story?
Yeah, okay, that's roughly what I thought.
Yeah.
Cool.
Well, I got that. I assumed that the granite was part of the rest of the, the last stage of the fractionation process, but I had wrote it down as an S-type granite because S-type granites are normally related with Grisons.
Well, if you go to the mineralogy of this granite, what's it got in it?
I know, but I didn't look at that. I just looked at my lecture notes where it was talking about cruciderite tin Grisons.
No. Yeah, I'm not saying
that they're typically.
I'm not saying you're wrong. I think it's a astute observation. I was just saying, how do we pick an S to an I-type granite? Do you know?
S-types have got more of the wall rock in them, so there's more aluminium, more felsic material in there.
Doesn't one contain magnetite and the other doesn't contain magnetite?
That's one way, yep. No, and so you're not wrong, Morgan. In a broader sense, the S-types are from a sedimentary source. So there's usually quite a simple way. The New England's a bit complicated, but the general rule of thumb is you follow the potassium. So I-types are generally full of pyroxene and amphibole. S-types have biotite and usually K feldspar.
So they've got a lot more pink in them, a lot more of that pink K feldspar in it.
Yeah, New England can be a bit weird because the I-types here also have K feldspar in them, but generally that rule of thumb follows, and the same as magnetite ilmenite. So you could go out with a magnetic sus, or you can actually identify, if you think you can identify as magnetite versus ilmenite, follows the same series. So based on that, Morgan, and what information you have on the mineralogy, what do you think the granite is? I or S?
I don't know.
Sorry?
But I've already handed it in.
Oh, you've already handed it in?
I've already handed it in. I've obviously got it wrong.
Oh,
initially I wasn't going to specify. I was just going to put granite.
Yeah.
You probably have. Then I thought, no, it's got to be an S-type, and my reasoning for that was the lecture notes.
Well,
that's my mistake.
No, you reasoned correctly. Yeah. So the granite is an S-type because it's full of biotite.
Oh, that's what I said. Yeah.
Yeah.
That's what I was saying. Oh, okay. I thought you said it was an I-type. That's why I was getting I thought that was an S-type.
No.
S-type is typically associated with Grisons.
Yes.
Well, Grisons are typically associated with S-types.
Yes.
Especially tin Grisons.
I have seen them associated with I-types too.
Have you? Okay.
Yeah.
Well, I've learned so far that with geology that there's whatever your rules you might try and impose on things, the actual rocks never play by that.
No, but in terms of a broad genetic, I think that's a fair observation. Yeah. And so then we have there's also a mineralogical distinction here. To be like, well, we've got all these pyroxenes and plagioclase, and up here we got this thing that's full of potassium, and is probably quite luminous.
Yeah, cool. No, I got it right.
Yeah.
I just wasn't listening to the conversation properly, I guess.
Yeah. Does that help, Josh? I think it sort of also answers some of Emily's question, or it probably makes it a bit more complicated about linking the Monzo granite to everything else.
Yeah, no, I think that mostly answers it.
Yep. Excellent.
What makes chromatite settle out? Then it makes sense that it would end up being an S-type granite at the end of it all as well.
What makes chromatite
settle out? What's that?
What makes chromatite settle out?
Doesn't chromatite normally? Doesn't those minerals normally fall into like complexing with pyroxenes and olivines, unless there's like an intrusion from wall rock, like there's some sedimentary intrusion into the melt to upset the chemical balance to force it into disequilibrium?
Not necessarily. You just got to saturate chrome.
Okay.
So, you got to saturate chromium. So yes, you're right that generally most magmas have mafic magmas have a fair bit of chromium in them, but it sits in a pyroxene. So we need a magma composition that has much higher chromium concentrations, and then it goes, oh, I'd rather go into chromite.
Yeah, that's what I was reading. I was reading it in the text.
Yeah. And so this is why
resource geology
in these big layered intrusions, these usually happen right at the bottom, because that's when we can concentrate chromatite before we've crystallized a lot of clinopyroxene. Because the clinopyroxene takes a lot of chromium, whereas orthopyroxene doesn't take as much.
Okay. And
the olivine takes the nickel. So if you have olivine, it's taking away the nickel. So we need to get to a point, and then chromite is very dense, so it's likely to settle. But as you can see here, the intrusion is layered, so people think it's like you got your toast, and then you have honey between it. So the toast, the honey can't get through the toast, so then we have little sort of convection cells between each of these layers, because we have this difference in viscosity. So then we can crystallize, all plagioclase in there, and the toast might be the chromite, or vice versa. And then so somehow the intrusion, and people don't fully understand, ends up with these rhythmic layers. It sort of separates, and then they can't mix back together.
I sort of wrote that up as the solution reaching like depleting itself in chromium, and then starts forming pyroxene, orthopyroxene. You get a layer of that, and then it becomes rich in chromium again. It starts dropping chromium out again, and then it becomes depleted in that, and it starts dropping out. There's not enough to make pyroxene anymore, so it starts putting it all into plagioclasts. Up the sequence until you get to the granites.
Yeah, well, at some point you run out of chromium.
Yeah,
you've got a finite amount. It's not just up. Yeah, so we've exhausted it, and it's not just chromite. Chromite is a good host for a lot of platinum group elements.
Yeah, I've read that Bushveld's really rich on that.
Yeah, and I think I told some people last week. So this is based on the Bushveld, but if you go looking for a lithium pegmatite in the Bushveld, or you tell people, isn't there a nice lithium pegmatite in the Bushveld? There isn't. I added that as something different.
That was the hard part I had, trying to justify the pegmatite in and trying to describe where it may have come from and how it's running like a massive dike right up through all the rest of the strata.
Mm-hmm.
I didn't have an answer for it.
Yep. No, that's good. So
I think I used the I won't say, because I don't think I'm supposed to be doing that. Don't want to send anybody else down the wrong path if I'm on the wrong path, which I probably am.
So
I did propose a hypothesis for it.
Well, that's good. Any other sticking points for people on Mount Mag? Pretty happy?
I was just with the stratigraphic column, are we just sort of like putting in like the layers of like the rocks that we've got? Or...
So this essentially for the column, I just would say you just make something like this, and you can actually put on the depths. So you have contours. So I don't know, what's the top one? You could say, well, let's start at 500. And then down here you'll have 0. And so then you'll be like, oh, this unit comes up this far, and whatever that unit is. That might be might be a chromite layer or something. And then you'll have something else here. And that's just the broad stratigraphic column. And at the top you'll have, some sort of granite or something like that. And I don't know, the pegmatite's a bit harder to put in there. You can put a pegmatite, I guess technically the pegmatite pretty much goes all the way through all of it. But yeah, so that's all to do with the stratigraphic column. So it'll be about giving an idea of how thick these things are and how they relate to each other.
Okay.
Does that make a bit more sense?
Yeah.
With the topographic map, it looks like it's all one rock type until it hits G23, except for the intrusion. Is that right? Or
Well, you got those grey areas.
Yeah, you got the grey, but when you go on A to A prime, it misses that grey area. And
but remember with geological cross sections.
Yeah, the grey's under it. Yeah, right.
We always want to interpolate about where the units are. So so on the surface we see something, but you know, when you're in charge of the drill rig, Ryan, I say, where are we going to drill? Where we can only drill in the area where there's no rock. I want to be sure that you know where we're going to intersect the payload, and hopefully it's not in the other direction.
Yeah, that's right. Yep. All right, cool.
Yep. So then, you'll actually have to project to see, and especially some of these black layers, about where they might actually be.
Yeah, gotcha. Okay. All right.
Cool. So people are happy with Mount Mag? What's left? Is there any other assignments left? People
No, just Mount Mag and the exam. That's it now, eh?
That's it. Nearly there. The other thing,
I'm just happy to pass. After all this, as long as I pass, I don't care.
well, P's equal degrees, mate.
That's it, eh? That's it.
What's the other one to say is that, you know, you walk out of an exam and you get your exam result back or whatever, and you go, oh, I got 51%. You worked 1% too hard, mate.
Yeah, that's it, eh? Yeah. You only needed the 50.
Yeah, exactly. Working too hard.
Yeah. As long as I get the 50, I'll be happy.
What was I going to say? For people doing 305, I know I've talked to a few. If you are doing 305, the rock kit will be a broader extension of the one you have. So let me know, and I will send out, instead of you sending it back for me to resend it back to you, I'll send out the additional samples, and then at the end you can send them all back to me. But I just need to know beforehand. Otherwise, I'll start hassling you for a rock kit and you'll say, I would assume that I needed it. So for people in 305, send me an email, let me know. And there's a couple on-campus students. We'll probably be able to return those in person, the current rock kits, and we can just make a clean go of handing them back.
I was thinking about doing 305, but technically I've got enough units after this to graduate.
Yep.
Because when I first started, I was doing I was going to double major doing remediation and hard rock mineralogy. So I've pretty much done that, except for 305. I need 305 to have my double major, but I'm not sure if I can even do it and still get hex for it. Do you know if I can?
I wouldn't know. You'll have to talk to the powers to be. I'd suspect.
Okay.
I would. Yeah, I'm not sure. I'd expect probably not, but I don't know. I'm just making an assumption. I don't know how often they get people going, I'm ready to do more, and they go, oh.
And the other thing I wanted to have a bit of a chat to you about is the honors. Like you sent a thing about honors. Like everybody sent an email about the honors meeting that's coming up on Friday, and it says it's just an honors in science.
Yeah, so that's I think it says a Bachelor of Science, but it'll give you an idea for Bachelor of Geoscience. You know,
so you can do it for geoscience as well.
Yes, yeah, definitely. Yep. You know, it's just it's broadly the same process.
And you just have to do whatever projects that they've got going at the time.
No.
You can pick your own research topics.
Within reason, yeah. You just have to talk to identify a supervisor and then, discuss what you might be interested in. They'll have an idea of what a problem is. And, there might be scope, beyond what's suggested. If you say, I'm really interested in this, do you have something? And they go, yeah, okay, we could probably put together something around that sort of line. Or
the other thing I want to sort of know is like, hopefully if I do all right in this and I do all right in GeoPhys, which I think I'm doing pretty well in that one anyway.
Mhm.
My marks are brilliant in this, but I should be able to push my GPA up to like maybe 5.3, or 5.1 or 5.2 or something. I don't know where it will go up to, but either way, if I take on, can I do a like sign up for honours and defer it, because I really need to get out there and work for a year.
you can. I don't think you necessarily have to sign up and defer. You
Just come
can
back
go
to
and
an honours and defer.
you can go and work and come back. There is a statute of limitation on that, but it seems to vary. I think you can have a couple of years, and then you can come back and get the honours for the degree you've got.
Yeah, okay.
And of course, I don't know. At some point, they draw the line. Like they go, "Well, you can't come back up to 10 years to get the honours." But I don't know what that specific time frame is.
But if you've done 10 years in the industry working as an exploration geologist, you'd be well primed to come back and and do a master's or something, or even do a PhD. From industry experience, wouldn't you?
Yeah. So, PhD is a bit complicated. PhD, you have to prove research experience.
Yeah.
But masters, yes, yeah. But yeah, like the honours is well recognised in Australia in terms of industry. Other countries have the master's program. They don't have honours, and the master's program is more dominant. But so a lot of companies will actually, people might be looking for jobs in mining. I know for a fact that the big companies, you can't even get into their grad programs without honours. They straight up say, we're not interested. That doesn't necessarily mean that you can't get a job. It just means that you might not be getting a job with Rio Tinto.
Right.
So industry recognises it well. On top of that, it will give you a leg up if you do decide to go and do a master's or a PhD. So honours can be enough for you to get into a PhD. If you don't have honours, you will be forced into a master's, and an honours might also help you get a Commonwealth assisted role in a master's degree.
Yeah, okay. So I think it's probably best to do it anyway.
It's up to it is a choice, but it is a nice cherry on top to differentiate.
From what I've been gathering, from what you just said, Ben, and from what I've been gathering, is that it's pretty hard to get into the industry flat out without honours.
Well, yes and no. I think there's been a few people, even in this Zoom, that have done it. So it's not impossible. But
Cool, I think a lot of the times. Now.
Yeah, but that's always the case, isn't it?
Yeah, but then I don't know anybody other than the teachers from school. I don't know anybody in the industry.
Yeah, no, it's hard to break in. But yeah, so I think honours is worth it. The other factor about that is you get some ownership over something. It's your research project. You're doing proper science. You're all doing science degrees here at some sense. But in an undergraduate we do a science degree, but we barely do any proper science. Honours is that chance to actually go, okay, how are we going to prove this?
That's the other thing too. Like for an honours, I know what I'd like to study. Like I'd like to study paleo climates, and especially in the Bowen coal seams, the Permian coals there. But either in that, but I don't know how well studying something like that, like paleontology, is going to set me up for, getting work afterwards within the mineral industry. Which, there's no work for paleontology unless you do a PhD and go on to be a lecturer.
Yes and no. Traditionally, paleontologists got a lot of money and still do get a lot of money in petroleum. The micro paleontologists get money thrown at them in the petroleum industry. They're very important for the drilling campaigns and to know where they are in the sequence. But yes, so that's another common thing. I mean, at the end of the day, industry, like, let's face it, honours is a 9-month project. You know, even if you did it on, you know, I don't know, copper porphyry systems, you're not going to become all of a sudden a world-round expert in copper porphyry systems from a 9-month. What industry recognises is a lot of the soft skills and the fact that you've done it. So having an honours automatically tells people you have committed a substantial written thesis, a 9-month project that involves time management. You've learned a whole bunch of skills along the way. You know, it could be handling data, field work, you know, how to go about completing this project. You've presented work in a written format, you've presented talks, you've been involved in a team of scientists to solve a problem. That's what they're interested in. You know, they look at it and go, oh, this person's done honours. How did they go in honours? Less so, oh, Morgan did his honours, but I disagree with what he's found, and I don't think it's very important for what we do. You know, at the end of the day, that means pretty much all research doesn't have a direct relationship to what most industry companies do. So I think that's less of an issue. But of course, if you're like, I'm really interested in, you know, I really want to go into lithium pegmatites.
Well, for me, it's all a question of.
And I want to study them and understand them more. Sure, there's probably potential for that too.
For me, it's and that's probably not a bad idea. If that's not a bad subject to study either. But for me, it's more like what I want to do as a job afterwards. You know what I mean? Being a bit pragmatic. I'm getting on, so the chances of me doing any world-breaking research is very, very slim. So going on and becoming a PhD in something, I don't think is going to happen. So then it's about what sort of job can I get from it afterwards, and the mineral industry is what works in Australia. If I do if I go down the paleo route, it's like you say, that's great for the petroleum industry, but I don't want to work for the petroleum industry. But it's interesting. Like if I'm going to study something, if I'm going to spend a year studying something, it's just far more interesting than hard rock.
I don't think. Yeah, I think there's plenty of scope for that. I don't think you're not going to get pigeonholed, especially if you have a geological degree. It's a different story if you've gone through and you have a paleontology major and you've done no geology. You know, the mineral industry is going to go, well, sorry, but you don't have the skills to hire you as a geologist. But if you've got that, if you've got those subjects, you're covered. So I don't think that'll be necessarily too much of a problem. So
the lithium pegmatite subject sounds pretty interesting. Is there much of that in New South Wales or in the East?
No, it's mostly all in Western Australia.
Sorry to cut in, Tim. Sorry, I've got to get going. There's one question I needed about this.
Sure.
Where it says submit for assessment, it says a sketch of a synthetic magmatic stratigraphy and the crystallization sequence of various magmatic. Is that the stratigraphic column?
Yep. And then label
That's what that is.
Yep.
Oh, cool. I was just making sure that wasn't something additional. That was all.
No, that's in there.
Awesome. All right. Thanks heaps for your time, guys.
No worries. See you later.
Thanks heaps.
Okay. So have I answered everyone's question about assessments? Make sure we're covered off there. Everyone's happy. I think most things are, pretty much due. So nearly there. And like I say, happy to help, especially with the exam prep. Let me know if there's, you answer a question or you're not sure about a topic, etc. Let me know. And we can...
With 305, it's just an extension on from this, isn't it?
Broadly, we'll start to get into more detailed look at ore deposits and specifically start to work through ore mineralogy with a microscope.
Okay, cool.
Yeah.
I think I'll enroll in that and do that.
Yep. So
they can only reject my request for a hex. If I don't get it, I don't get it.
Yeah, well, I'm sure they're happy.
If I don't get it, it will be a short-lived attendance.
I'm sure they'll be happy to take your money.
Yeah.
So they're and if people are interested in honours or what next, etc. Yeah, happy to chat about that as well. But feel free to attend that session, especially for the people that are, I guess, getting to that stage of their degree. But people in second year, it's definitely worth thinking about what to do down the track. I've found it a very fulfilling year. I had a very enjoyable. It's a lot of work, but like I say, I think it was nice because I actually felt like a scientist instead of someone reading, just essentially regurgitating other material.
A school kid.
Yeah. So I had some ownership of some things, and and I think there was unit surveys as well. Feel free to do them. I know it's been a bit of a torrid trimester. With a range of challenges, but I've been impressed with how everyone's come together and gotten through them. So I thank you for that. And well done, nearly there. And for those doing 305, I think you're in for more disrupted pain, but again, we will get through it. To provide context, the intensive school for 305 is currently considered mandatory, but I'm fairly certain that it won't be, with the possibility that people maybe in New South Wales and maybe Victoria might be able to come, but I'm pretty certain that other states are not going to all of a sudden open up to New South Wales, especially Queensland. Queensland sounds like they might not ever open up again. Currently it is, so I suspect that'll force the hand to make it non-mandatory and quite possibly online. So we'll just see how that goes. So it's a bummer, but we just deal with that as it comes through. And there's a few things that I have to chase up, I think, for you, Josh, as well, to see when we can put that exam so you can go off to start your job.
Yeah, I'm still deciding when I want to go. I got to talk to them, I think, this week or next week. They're going to contact me. Okay, yeah, because I know there's a few people in your shoes. I think Taylor will be the same, won't he? Yeah, I think so. He's got stuff to do over Tri3, but I think he's got to do another unit, I think, as well. So he's got 2 units to do.
Yeah. So yeah, I haven't even considered when that'll be yet. So I have to get across those as well.
Well, I think it's all wrapped up by February, isn't it?
Yeah, that's my understanding.
Yeah, because I'm going to try push it out to mid-Feb if possible.
Yep. Yeah. So yeah, we can come up with something when we have to, and go from there. So, all right. Thanks everyone. Good luck with study prep. Let me know. Happy to help. And yeah, stay safe. There's no more.
All right.
Excellent. Thanks, Tim.
Thank you.
Thanks, Chris.
Thanks, Tim.
See you.
Thanks, everyone. Oh, yeah, I recorded this. So.
Oh, sorry.
You got a question, Chris?
Is it going to be another tute before the exam next week?
I hadn't planned on it, but we can arrange something if people want a chance to answer some questions. I'm happy to do that. Maybe we won't do it the night before. Maybe we should probably. That might just cause a bit too much anxiety for people. I don't know. We can, if people are interested in that, we can put it on maybe on the Monday or Tuesday or something.
Okay. No worries.
Would that be something you'd be interested in?
Probably see how we go. See how we go after.
Let me know.
It's a bit about May, but yeah.
Yep. And same for everyone else, but yeah, happy to. We can put something together. The kids are ready for you, mate.
Yeah.
Hello.
Excellent. All right. You can wave along. All right. Okay. All right. See you later.
See you, Chris.
Bye.
Right, cool. Thanks, Tim.
No worries. Thanks, Josh.
Josh.
I'll be in touch at some stage. Yeah. Morgan, honest stuff. I've been slack. I need to send that you're interested to Marissa. Let me do that now.
Okay. Cool.
I will do that. But yeah, so I would say for you, I don't think there's no need to get too caught up with if you're doing something in the mineral industry or not. I honestly don't think it presents an obvious advantage. The times when it is an advantage is you might be doing a project with an industry partner, and at the end they might say, oh, by the way, we need a geologist. You know, are you interested? That's probably the most direct one. But in terms of when they pick up a thesis and they just go, oh, Morgan, honours, excellent. What does he mark? All right, what's he done? Yeah, it looks good. You know, let's put him in for interview. You know, they're not going, oh, well, Morgan's with paleontology. This one's, you know, about lithium pegmatites. We're all about lithium pegmatites. You know,
lithium pegmatites sounds interesting as well, but getting all the way over to Western Australia sounds hard.
Yeah. Well, you know, I think that, well, I don't know. Well, Western Australia's got to open up at some stage.
Yeah, but in terms of just getting over there financially for the if I'm studying, doing
so honours, they also provide money for you to do your honours work. So most of the time it goes to analytical costs. You know, it's an internal fund. You can't, you know, it's not a slush fund. But you know, essentially that'll cover costs of field work, or if you've got to get some certain analysis done, that's there to do that. So don't stress too much about that. Your supervisor has to consider sort of, is the project feasible? All right, so I've started that potential honours, so I should be able to finish that and pass it on to Marissa and see if she but have a think, go to the session.
Who's Marissa? Marissa's running the honours program this year.
No, so she's a paleontologist.
Okay.
And I just know that you said you were interested in those paleontology style. What is she? Invertebrate paleontologist. So she works on Cambrian stuff, but she's interested in, there's big log jams in the Boy